So we also need to know substituents. And sometimes a hydrogen atom is replaced by one of these substituents, and we will discuss these as we do some sample problems. So first, we're going to try to name this compound. So first, we notice that this compound has a triple bond right here. And since it has a triple bond, we've learned that that means it is an alkyne. And so, now that we've identified that it's an alkyne, we are going to count the number of carbons that are continuously linked, or the longest chain. So we're going to count 1, 2, 3, 4, 5, or you could go 1, 2, 3, 4, 5. But either way, you can get 5. So that's 5. And since we already know it's an alkyne and there are 5 carbons, we know that it is a pentyne. You need to know these prefixes. 5 is pent. And then we're going to number these carbons so that the triple bond has the lowest number. So to number, we're going to go 1, 2, 3, 4, 5. So the triple bond has number 2, and we're also going to identify our substituent group. And so since here's our chain, this must be our substituent group, and the CH3 is the methyl group. Then we're going to name it. So first we're going to start with the substituent. So the methyl group is on the 4th carbon. So we're going to write 4-methyl. There are no other substituents, so we can move on to the pentyne. The triple bond is on the 2nd carbon, so you're going to put 2-pentyne. This is substituent number. And here is where the triple bond is. We're going to try to name this compound. So first, as always, we're going to try to identify the functional group. Here, the functional group is right there, and we identify it as this, which is an ether. We're also going to try to identify our substituent group or groups. And so here and also here. So the CH2CH3 is the ethyl group. So now we're going to name our ether. Since there are 2 ethyl groups, the name is diethyl ether. Now our third example is this compound, and as usual we're going to find what the functional group is. And we're looking through this and we notice here is the hydroxyl group, which indicates an alcohol because of the OH. And so first we're going to count the carbons, which are in a continuous chain. So we're going to count 1, 2, 3, or you could go 1, 2, 3. Since they're both 3, it doesn't really matter which chain you choose to use. I'm going to choose this one. And that means that that one methyl group sitting there is our substituent. Now we know that there are 1, 2, 3 carbons. So the prefix is pro. And since it's an alcohol, we know this is propanol. Now we're ready to name our alcohol. So first, as always, we're going to start with the substituent, and we're going to number the carbons. 1, 2, 3, so that the substituent has the lowest number when numbering. And so since both ways, 1, 2, 3, the substituent group is still going to be on the second carbon, we are going to put 2 methyl, and since the hydroxyl group is also on the second carbon, we're going to put 2 propanol. For this example, we're going to name this compound, and as we've done so far, but first we're going to identify the functional group. And here we see that the functional group is right here, and it is that, and that's a ketone. Ketones have the suffix ONE. Next, we're going to count the carbons so that the carbonyl group which is the C-double-bond-O, the carbonyl group, has the smallest number possible. So since there are 2 carbons here and just 1 here, I'm going to start over here. 1, 2, 3, 4. So since there are 4, the prefix is but, and since it's a ketone, it is a butanone. And so we're going to name it, and first we're going to identify if there are any substituent groups. In this case, since there are 4 carbons and we're including it in our name, we're not going to have any substituent groups. So we're just going to go ahead and specify where the carbonyl group is, and this is on carbon 2, so that is 2-butanone. Another way to name this ketone is to see it as a ketone with the methyl over here can be a substituent group, and that there is the parent chain. So you can also see it as methyl, which is the CH3 substituent group, and ethyl, which is 1, 2, 3. Ketone. That's an alternate version of how to name that compound. The next example, we're going to name this compound, and as we've always done, we're going to find what the functional group is, and it is right here. So the functional group in this case is actually the ester. For esters, the suffix can be OATE or maybe ATE. And so the first step, as always, we're going to count the carbons. The thing to note about esters is that the parent chain is always on the side of a carbon, right here, and the rest can be substituent groups. And so we're going to count the number of carbons in the parent chain. 1, 2, 3, 4. So there are 4. The prefix again is but, and since it is an ester, the compound is a butyrate. We want to number it, so the carbonyl group, remember the C-double-bond-O group, has the lowest number possible. So we're going to start from here, and 2, 3, 4. So that's 1. So here is our substituent group. This is actually an ethyl group. Since it is on carbon 1, we don't need to specify its number. We just need to say ethyl butyrate. So that's the name of this compound.